In the team Embryonic Neurodevelopment and Childhood Cancers, led by Valérie Castellani in Lyon, we are trying to understand how cells orient in space during embryonic development, and particularly during neurogenesis and brain development, axonal navigation, and cellular migration. Like migratory birds, cells and future neurons navigate over long distances in the embryo and are guided by topographic landmarks. For some years now, a part of the team has been studying the alteration of these processes in the pathological context of pediatric cancers derived from the nervous system, and mainly neuroblastoma and medulloblastoma. Indeed, pediatric cancers occur while morphogenetic programs control the proliferation of progenitors, their amount, their migration, and their organization in the tissues. The malignant transformation affects these progenitors early while they are still migrating toward the territory in which they will form a neuronal structure. So in pediatric cancers, the malignant cells coexist with their physiological counterparts. And this is key in our understanding of the tumorigenesis mechanisms, but also in the design of therapies for children. If we follow our analogy, hungry birds would sneak into a swarm of migratory birds, take advantage of the resources and rest areas, updraft, tailwind, and gain a selective advantage over the normal bird's population. We study the imprints of the embryonic microenvironment on the behavior of malignant cells. We assume that tumoral cells adopt phenotypic identities of their physiological counterparts in order to take advantage of the developmental mechanisms. Our ultimate goal is to define the characteristics shared between physiological lineages and tumoral cells, and those specifically resulting from malignancy. The underlying idea is to specifically target malignant cells while preserving healthy embryonic tissues.